So let's talk about prompt templates. We're building on what we know about prompt engineering. Now we'll design effective ones. We'll start with the basic structure. A good prompt template, you see, is made of different parts. These parts are separated by clear markers. They guide the large language model. Think of it like a blueprint, a really organized one. There's the system role and the persona. This tells the LLM what it is and what it shouldn't do. Then the context block. This is where we put in information, like document chunks we retrieve. Next, task instructions and constraints. These help stop the model from making things up and guide its behavior. Of course, there's the user query, what you're actually asking. And finally, output format or style control. This makes sure the answer is shaped right and has the right tone. Separating these blocks clearly is important. It helps the LLM know what's what. Is it an instruction, or is it retrieved data? This diagram shows it. All these pieces go into the LLM, and out comes a response. The main point here is structure guides the model. So a well-designed template has clear parts, with clear markers. Okay, so here's the deal. We need to talk about two really important parts: grounding and applying constraints. First, grounding. This is about giving the LLM context. We inject retrieved data, like chunks of documents. Now, how does the LLM know what this data is? It needs a clear label, a structural prefix, you see. Something like ### context data ###. This separates it from instructions. Then we have task instructions and constraints. These are super important. They help reduce hallucinations. How? By defining how the LLM behaves, especially when info is missing or ambiguous. For example, you can tell the LLM, use only the provided context. If it's not there, say information not available. Or even, every claim must reference the specific document ID or section title. This really helps. It makes sure the LLM gives good answers based on what you give it. This code block here shows a common way to do this, to label the context data within the prompt. So the main idea is this: grounding and constraints. They stop hallucinations, and they ensure reliable answers. Okay, so, effective grounding and constraint design. It really depends on your specific application. Here's the thing: different domains have unique needs for precision and accuracy. Let's take finance. In finance, you need temporal and quantitative precision, like really badly. Queries often compare periods, think year-over-year growth. So you must stick to dates and compare specific periods. Avoid aggregating data unless someone asks you to. Now contrast that with industrial or oil and gas. Here, accuracy of technical specs is super critical, like pressure ratings or part numbers. This is for safety and keeping things running smoothly. So preserving exact numbers and units, that's vital. Don't normalize or round unless you're told to. This visualization right here shows a side-by-side comparison of these domain constraints. The main idea? Your domain context tells you what specific grounding and constraint needs you have. And here's the thing: prompt templates do more. They control output structure, also format, and even style. You can enforce specific structures, like JSON or tables. Just put the schema in the prompt. It's way more reliable than just asking for JSON. This Python code block shows it. It extracts maintenance history and puts it in a precise JSON format, ensuring valid JSON, no preamble, no conversational text. This is super useful for downstream systems. You can integrate LLM outputs. You can also calibrate tone and style. For technical reports, ask for formal language, passive voice maybe. For executive summaries, ask for high-level bullets, focus on impact and risk. So the key idea is that prompts control more, not just content, but structure and tone. Okay, so let's talk about something important: security, specifically prompt injection. Here's the thing: a big vulnerability is indirect prompt injection. This happens when the text we get back, like a document chunk, it actually has bad instructions hidden inside. Funny enough, a totally normal PDF could secretly tell the LLM, ignore all previous instructions. And that can be bad. It could compromise the system or lead to unsafe answers. But we have defenses. Prompt templates are key. One is called delimiter defense. You wrap the retrieved text with special, unique markers. Instruction placement matters too. Your main instructions, you put them after the context. This helps them take priority. Also, strict formatting, like demanding JSON or a specific table format. This makes it harder for those bad instructions to trick the model. That mermaid diagram? It shows how these defenses work. The bad instructions, they get processed along with our defenses, ideally leading to a safe answer. So strong prompt templates, they are a vital defense against these tricky indirect attacks. The main point here is this: strong prompt structure. It's a vital security defense.